upside down sock things. Yeah, no, I'm not. Yeah, reverse suspenders. Yeah, great. Then I look like Borat, right? And that thing that he wears. Oh my gosh. Okay. Make the rocket more pointy, not pointy. No one's scared of a round rocket. All right. Pneumatic cylinder. The pneumatic cylinder, air came in through the bottom, traveled through the middle of the shaft because the air has to come out up here to push this piston down to lock the wheel in place, which means this is, I don't know, we'll call it 6.5, 7 inches times 4 inches times pi d. That's a lot of math, so I don't feel like doing it. At 100, and now you got to multiply it by 120 psi. So there's a lot of squishy going on, okay? So the original one, like this is an original one, we decided that 4 whole entire bolts was enough to hold this together. Well, it wasn't. So then we went to 8 hole bolts. But the other thing is if you notice, these bolts come in from the bottom and they're black. So who notices that the bolt that comes out the bottom, the black bolt, in a tire changer is going to notice that there's not a little black thing right here, right? So then we made them out of silver. At least this one got the upgrade. Right, so then we made them out of silver and we went from 4 to 8. There's some other things we did inside to bolster it, to make it a little stiffer. Anyway, so the air used to come into here and this pushed down. This had a lot of throw, so you didn't really have to make sure that the center clamp was all the way down, okay? The pneumatic, the hydraulic one only has a very short throw, so you got to get that thing right on top of the rim if you want it to actually lock down, because it'll pull it down. It's only going to pull it down about yay much. Okay, so the pneumatic one had a lot more throw. Again, for reasons, we no longer sell anything. You can't get the piston, you can't get the top hat or the bowler hat. You can't get anything for this spindle. This spindle again was replaced. We changed over to the hydraulic spindle sometime in 2020 because COVID was going on, and we made the video and call it, I don't know, July to September 2020 is when we made the video. So about that time we started shipping them out at the same time, so we had to make the video on how to do it. Okay. All right. So a couple of other things that just for you guys, this other one here also had some other things. The top bearing is here and the bottom bearing is here. So we didn't have a lot of bearing separation. So it has a little bit more wiggle room left to right, especially if you're doing a hard tire or something like that. So there was a lot more stress on the bearing surfaces. The other right here, it's on my side. So fine. You can't see it, but where the wheel encoder is. By the way, your wheel encoder should not do this if your spindle is not spinning. Because if your wheel encoder spins and your spindle don't, so on the older one where the wheel encoder was, the hole was too big, and the wheel encoder reader, they had slots in it, and you had to like put it on and push it up and down and up and down and up and down and up and down and try to find the middle, and then you screwed it down. And if you pushed it it didn't matter so much if you pushed it up too high, but if you pushed it down too far and tightened it up, the plastic would start to wear, and then it would get all sort of dusty, and then the dust would cover up the dust would cover up the windows, and then you were back to breaking TPMS sensors. So when they redesigned the spindle and we went from pneumatic to hydraulic, one of the first things they did is the bottom bearing is all the way down here, like you can see, and the top bearing is now all the way up. Well, it's right here. So we have a much better bearing separation, so this shaft here doesn't have as much flex. The other thing we did is we just went to hydraulic, okay? And I'll explain that in a second. There is basically the best thing I can tell you, this we call it the wiper diaper, because this is a sealed bearing which has grease in it. But when you get into places like Corpus Christi, Texas, the grease turns into liquid, and then the liquid drains down onto the wheel encoder, and then the wheel encoder can't see, and then you're breaking TPMS sensors. So rather than fixing it, we give you this piece of foam which basically sucks up all of the grease that spills out of it. And when this foam starts to leak over and you do end up breaking TPMS sensors, you just call up the Hunter Service Center and you say, hey, send me some more wiper diapers, and they will send you these for free because that's our fix. You just keep replacing wiper diapers until the grease runs out of the bearing. Again, I don't even think we really need, because how fast is this thing turning? 5 RPM, 6 RPM, maybe. So like if this bearing was dry, it really wouldn't be the end of the world. It's at 6 RPM. It is a sealed bearing.
And it still gets up? It'll still leak out.
Well, a sealed bearing's not like hermetically sealed. It's just mostly sealed. It's sealed enough. It's called sealed. The reason it leaks out is because it's on its side. If it was straight up and down, it probably wouldn't leak out nearly as much because it would puddle and it would keep slapped. It would almost like an oil sump, right? But because it's on its side, it actually seeps out like where the seal actually hits the race. Okay. All right. So if you notice down here, we have a giant spring. That's because you only have one hose that goes to the spindle, and that hose has to put oil, ATF, into the spindle to draw it down. But the giant spring's job is to push it back up so that it expels the oil, so that it unclamps the wheel. Okay, so let me see if I can do this. There should be an orange O-ring here. There should be an orange O-ring here. Any of you guys ever resize Teflon seals? Okay, yeah, you're not allowed to do that. So.
Thank God. That's fine with me. I figured you just had some big cones.
Yeah, the same ones we use in the press. We use those. Okay, so these two, what did I just call them? Teflon seals. Thank you. That's the only thing keeping the oil in. Okay, so no Teflon seal is perfect. So what ends up happening is oil will leak by the Teflon seal. It'll get up in between here, and then when you use this, if you never use this as a tilt, the oil never can get to here because you'd have to have a lot of oil. But as long as you get a few drops into here and then you tilt it down, if you notice, this is a downhill path. So the oil that leaks out of it runs downhill due to gravity and then runs slap into your wheel encoder. And then, of course, it blocks the windows. And then, of course, you're back to breaking TPMS sensors. So,
is that an optical or is that a Hall effect?
It is a optical, because we're shooting lights just like the one in the on-car brake light. Okay, so this one here, it's not brass. It's a weird, it's a weird plastic. I'm not really sure what type. It's like a laminated plastic. It's a weird laminated plastic.
How often do those seals go bad?
All the time. So, 2 more seconds and I'll get there. So.
I know you're going to tell me it's because we're an engineering company, right?
Answer 1. Answer 2.
Why don't they just go to like a magnetic one like we do on crank sensors and cam sensors? Like a reluctor wheel?
Because it's surrounded by metal.
An engine surrounded by metal?
Yeah, I don't know.
It's cast aluminum, but it's still surrounded by metal. You think?
That's kind of embarrassing. You know what I mean? In the teeth,
well, but a crankshaft sensor, the magnet's at the tip of it, and then the reluctor wheel is on the crankshaft, and it's not actually close to the metal.
Exact position, and it's a freaking.
Yeah.
I bet you magnets are more expensive than that.
I think it's because we started with a. It works for us in balancers, and it works for us in brake lathes. So we have a long history, and the ones in our balancers, we've had those optical wheel encoders since the early 80s. So we have a long storied history with optical wheel encoders that have and it's not the optical wheel encoder's fault that it gets stuff on it. So the optical encoder is failing, but it's not failing because the optical encoder is failing. It's stuff is getting on the wheel encoder. So we've had I can't even do math right now. 85 to 25 is 40. So we have over a 40-year history of using these in what we do. So this is just what we do. And sometimes engineers can be a little stubborn into adapting to new technology. So anyway, So what we do here, if you notice on this Teflon seal, this little rubber dude didn't used to be here. So as soon as you leaked out anything, it would leak on top of that. Then we give you this little rubber plunger, and the rubber plunger sort of seals off against the shaft and the outer piece of this. So now you have to fill up this whole void with oil before the oil will finally push its way past the rubber plunger and then get on here. And we did that because
We're an engineering company.
work it out. If it takes longer to get through here, I'm getting further through my warranty period. And if I can get out of my warranty period without replacing as many because I put in $1 rubber plunger, I'm okay with that, right? Because if it fails at 4 years, not under warranty anymore. So unfortunately, they fail more often than we want because the eagle-eyed viewers in here will notice that this is aluminum and we don't put a steel sleeve in it. If we would steel sleeve this, it probably would last a whole lot longer than they last. But by not using a steel sleeve, we're saving money. So we just use a big old honking thing of aluminum. So here it is. Right here. So when you have to replace it, you have to replace this whole piece. So you're going to replace this. Okay. The piston, which you're now not allowed to touch or not allowed to size, is already in here. So here's the bottom of the piston. So what you're looking at is this. Actually, you're looking at this. So that's what you're looking at. You're looking at the bottom of the piston. We size the piston. We make sure that the walls are honed very nice and pretty. But again, it is just, I don't know, who's got a magnet? Is it steel or aluminum? Okay, so it is steel. Oh, it is steel. So we don't need a steel sleeve. Is it inside too? It is steel. Okay. Well, it is.
The black is not.
No, but that's plastic. But at least we do have, so I don't have to sleeve something that's already steel if it's steel. I can't put a steel sleeve in steel. That'd be silly. So the next thing I'm going to talk about, and you guys are a lot smarter than I am, I didn't understand how when I put oil into this hole and oil hit here, that it made something move up and down until somebody